So good afternoon, ladies and gentlemen. It's a pleasure to be speaking at today in the Blue Sky Thinking session of the Biannual Conference. And today I'm going to describe our vision at Tata Steel for the future of steel-enabled sustainable construction. And there's a lot to get through here, so I'll be quick and speak quick. So I do apologise up front, but I'll do that by trying to describe the context for that vision in the construction sector, the vision itself, and the challenges and potential pathways around that vision. So if we start with the construction sector context, today the construction sector has a number of challenges facing it. Some of these challenges aren't terribly unique to the construction sector, but challenges of the construction sector all the same. Fundamental across these challenges, are fundamental across the three dimensions shown here. So the sector has a productivity gap versus other industries. And whilst industries such as automotive and retail have increased their productivity by well over 200% since the 1940s, construction has made very little progress. Developments are required using technology along with new business models to provide for improved engineering, design, improved productivity with enhanced in-use building performance. In sustainability, I think many on this call will know, but the built environment in the UK is responsible for something like, if you look at the latest UK GBC figures, something like 25% of the total UK carbon emissions. And on a global basis, the sector is responsible for around 50% of landfill waste. In terms of digital integration, there's some good news here in that there are affordable and powerful digital tools that have capability to deliver the changes needed, but the integration of these technologies across supply chains and across the construction life cycle is a significant challenge. In summary, these challenges require a construction transformation to deliver affordable, efficient, safe, and healthy buildings. So in that context, I'd like to describe our vision for the steel-enabled sustainable construction. And that is a digital, smart, and connected construction environment where transparent and responsible supply chains produce durable, resilient, and sustainable steel products, which deliver sustainable performance through their lifetime. And at the end of that life cycle are used again. And if not used again, then they're returned to where they were produced to be recycled in a carbon neutral cycle with zero waste. So if we were to examine the challenges and potential pathways to this vision in a schematic, particularly if you've got a poor imagination level like I have, then it would probably look something like this. So the challenges involve unlocking the challenges of the vision involve the complete steel and construction supply chain. The availability of low carbon steel is critical. The design and construction processes are core elements, as is the in-use phase of the products, the buildings themselves and how they're used. And end of life and circular economy are critical if we're to reduce waste and future resource use. Then shown at the bottom, rather underplayed in this schematic, but it's the only way I could think of fitting them in, is the foundation of digital processes, digital tools, and data, which will underpin and enable most, if not all, of this vision. So if we use this schematic as our map over the next 12 minutes to describe the challenges and potential pathways to that vision, starting with the steel supply chain. So Stephen's already mentioned in his presentation about transparency, reporting, and a just transition, which is absolutely essential. But a key part of our work here in working with the steel supply chain and the construction supply chain is around transparency and reporting. And it's also, those two items are the foundation of our sustainable development work within Tata Steel. So within Tata Steel, the sourcing from responsible supply chains and our responsible operations are at the core of what we do. Two examples here of that important work is around the left-hand graphic here, which shows a BES 6001 certificate. And BES 6001 is a responsible sourcing framework originally developed by the construction sector, as it happens, covering organizational management, supply chain management, and the management of sustainable development. Our entire construction portfolio across Tata Steel, 14 product groups in total, is certified to this third party and audited certification. In the center of this page is something I'm rather proud of, actually. It's a governance document for Tata Steel's Environmental Product Declaration Program. And Stephen already mentioned some ISO standards around declarations. And environmental product declarations, for those that don't know, are a standardized way of describing the impact of a product in environmental terms over its whole life cycle, from raw material extraction to end-of-life disposal, reuse or recycling. And Tata Steel operate the only manufacturer-led ISO EPD program in the world. And we now have over 50 EPDs across our construction portfolio, all of which are third-party verified. And I reiterate that transparency and reporting must be the foundation of that construction transformation. So moving on to the availability of low carbon steel, very topical, of course, for this webinar overall, or this event overall, but I'm not going to spend a lot of time talking about that, because Tata Steel have some ambition here. Within this decade, we'll achieve a 30% reduction in our CO2 intensity, and are working on moving our downstream product manufacturing facilities to carbon neutrality. And one of our main sites in North Wales, in Shotton, will achieve this by 2040, or earlier. And by 2050, we will be a carbon neutral steel maker in line with the Paris Agreement. Now, I don't put a graphic here about just transition. Transition is a really important part of that, and unfortunately in this presentation I haven't got time to talk about that, but maybe we'll do another webinar another time. So moving on to design and construction, here we'll focus on the productivity issue, which is being addressed through a number of potential solutions, and one of those is a modern method of construction called construction platforms. And the concept's pretty straightforward. It's based on the premise that buildings are designed at the moment as somewhat unique one-offs. This leads to a massive variation across building design and construction, and is the antithesis of economies of scale. And if you compare that with the automotive approach, where an automotive company might have 3 or 4 chassis, which are the foundation of its 15 or 16 models. Now, the construction platforms approach borrows from this, with a small number of standard designs for building types and a relatively small number of parts or products, which, like the automotive sector, are homologated as well. This allows for standardization across the products, and with the building components fabricated and built off-site, which can then be rapidly assembled off-site through automated processes. All this helps to deliver the productivity improvements we've been talking about, and as well as building with lower carbon intensity in a safer and more cost-efficient environment. Now, the picture you can see here on the left at the top is a kit of parts for a building called The Forge in London, situated behind the Tate Modern. It's just about complete now, and it's built on the site of an old metal foundry, hence the name. It's a £140 million office development, and was designed and engineered by Bryden Wood, and is the world's first major commercial construction platform build. So Tata Steel have been heavily involved with a number of external parties around construction platforms, including this project. Now, the project was awarded funding from Innovate UK for its innovative design and groundbreaking construction techniques, which were planned to be used, which including allowing stories to be built using the floors below as working platforms, which of course assists safety as well. Now, Tata Steel supplied the steel to the hybrid concrete and steel main framing solution, and steel was chosen primarily because of its ability to be fabricated in the columns and beams off-site. The secondary framing uses novel beam assemblies to effectively create a ribbed concrete slab, allowing exposed structural solution, which my colleagues who visited the site said it looks pretty cool too. Now, the beam system was developed through an interuse of one of Tata Steel's main decking products called Confloor, but it was inverted and used as a beam, and that's shown in the bottom left there. Now, these were jacked up into place from the floor below, allowing a much safer working environment. And this smart use of steel, and I did see in Stephen's presentation, how long can an industrialist go without quoting an environmental figure? And I was thinking, I haven't got one, that's fantastic, but I have. That it saved about 20% on the embodied carbon on the steel and the concrete to take this approach. So we could have talked about other modern methods of construction and the suitability of steel across those modern methods, but unfortunately we don't have time. But if any of these areas are of interest, or this slide's of interest, I'm not the expert on this particular aspect of Tata Steel's work, but my colleagues are. So please do contact us to talk about it if it's of interest. So moving on now to the in-use phase, steel is already enabling in-use energy savings through both established and novel product technologies shown on the left of the page here. And many of these of those products on the left there have been developed with colleagues at Swansea University, some of which are on this call and certainly have been on this event. But I'd like to focus on the right-hand side for the moment, which is more about monitoring of in-use performance. Stephen's already said, if you don't monitor it, you can't improve it. Yet we have a similar saying in Tata Steel: if you don't monitor it, you can't manage it. So monitoring of in-use performance of buildings is an area that the construction sector really lacks data and understanding. And this feeds into an inability to understand performance gaps and how we might improve on those. So on the right-hand side of this slide here is an example of how steel-enabled construction products can assist in this challenge. So these are two insulated built-up panels with an array of embedded sensors and monitoring equipment. They were produced by their Tata Steel panels. They were a Blue Sky pilot panel, and they were for an event in one of Tata Steel's facilities. But they demonstrate that the technologies and the capabilities exist to drive improvement in this area of in-use performance monitoring, and steel-enabled products can play an important role. So we're moving on to a quiz, which might be rather boring because you can't shout out the answers, but I'd like to do a quick quiz on a spot the difference. So here we have two pictures of the same skip, which is in front of the garden of one of my colleagues who's having a new kitchen fitted. In the skip on the left, we have a range of waste materials, lots of waste wood, which is typical of a construction project, some concrete, some glass, and a couple of steel and cast iron items. Effectively the oven that he was taking out and the iron grating from the hob itself. And on the right hand side, we have an image taken only a few moments later. And so can you spot the difference? Yes, the metal's gone, the steel's gone, the iron's gone. Why? Well, because our local circular economy operatives have removed it. And that's because it has value, and that value will enable circular economy. And that material will go back into a steel supply chain. And I think most people, certainly a lot of people on this call, will be very aware of the credentials of steel for recycling, and there's still challenges around that. Contamination, Stephen's already mentioned, but we mentioned in our vision reuse, which is where we would also prefer to be in terms of the waste hierarchy. And here we have a project developed with the Dutch Steel Institute, Baumet Staal, and building development company called Delta Development Group, and Tata Steel was involved in this project. This is a project for a distribution center at Schiphol Airport. It's a couple of years ago now, admittedly, but it was to create a 100% circular economy building by adopting practices which would enable high reuse rates. And to enable the reuse of the components needed to be demountable, they needed to be modular by design. And in the steel, this was achieved by adapting anchor bolts for demountable beams and column connections. All the cladding connections weren't shot connections, they were demountable connections. And the design utilized standard beam and column dimensions for the entire build for consistency through the build. And standardization, of course, is only one of the many, many challenges for a future reuse market. And all the materials were catalogued in a building material passport or a database containing all the steel specs and dimensions for future reuse reference. So finally, a key to much of this vision that I've described today and those pathways and challenges is what I've described here, is data, digital processes and digital tools, both through the steel and construction supply chain and the life of the steel product or the building. And I'll focus here on one aspect as an example, and that's our work at Tata Steel on our tag and track development. So this concept is pretty simple. As soon as a steel product is born, it's tagged digitally. And through the digital marking, it can be tracked through the supply chain, onto site and into construction. This has a number of benefits. At its most basic level, you're able to identify the product In addition, when you use the digital mark, you access a host of information on that product, from mechanical and dimensional properties to the chemistry of the product and its environmental impact in manufacture. And the above images show our initial pilot work, which is still ongoing. And this was down at the Construction Platforms Research Centre in Southampton. And the QR code on this steel structural hollow section, which I think was manufactured in Hartlepool, directs you to a product landing page, which is shown there on the graphic on the right hand side, and giving you access to a range of customizable data sets. Now, the scanning and live tracking of the product through the supply chain onto site, at the site, allows further benefits both through that entire supply chain and, of course, in construction efficiency. And at the end of life, such data is invaluable in identifying the product. And if we build on that data with the Inuse performance monitoring data I talked about earlier, we have information which more easily allows us to consider and more economically consider product for reuse. And as a final point, I haven't had a chance to talk about this in 15 minutes, but new business models are going to be required to deliver on this vision. So if we lay the foundations for a more sustainable reuse market, then it becomes important that we consider, well, how, Stephen's already mentioned it, we need to make money to remain in business. We need to make money to continue our work. And therefore, if we're going to use less steel in the future by enabling a reuse market, then we need to consider where those revenue streams are coming from and how we can generate revenue streams through the life cycle of the product, not just at the point of sale. And the provision of data could be one of those areas. And a tool to deliver that full provenance in these products, which are designed to be demountable, and we have monitored them in their use, performance, then at the end of life, we have a pretty good understanding of those products, what they are and their condition, which starts to be able for us to consider taking back that steel product for reuse or other purposes. And if we go a stage further, we could start to consider steel as a service rather than a product in leasing construction steel products, because we're involved in the complete life cycle of that product and that building. So there are significant challenges here, particularly in construction, not least along the very long life cycles, commercial building, an average of about 60 years. But in considering this as our vision and examining these pathways and challenges, these are the interesting challenges that Tata Steel are working on at the moment. And that concludes the presentation, Dave.